Hello, everyone. We're going to talk about a topic that's kind of near and dear to my heart today, which is tree risk assessment. I'm recording this lecture from my kitchen right now, and I have a new puppy that is running around the house, so I might get a few bits of that in the recording. It'll just be for your enjoyment. We'll talk about tree risk assessment basics, the tree inspection process, various defects that we've noted in history as being something that may predispose a tree to failure. We'll talk about the importance of species profile and site history. We'll briefly go over some advanced inspection techniques that we'll show you at the field day, or you may have seen already by the time you see this. And then we'll talk about risk management and mitigation, and we'll finish with a few legal terms regarding liability and negligence. I first became interested in tree risk assessment when I worked at the International Society of Arboriculture. When I was there, I was a science and research manager, and I handled a lot of questions from news agencies and the public. And I remember this story quite vividly. This is something that came out about the same time period my first child was born. And there was a mother that was at the Central Park Zoo. She was just walking with her newborn on a calm day, and a branch fell and struck both her and the newborn and killed the newborn. And it really kind of it just got to me, it was just too close to home. So I thought, if there's anything I could do in life to prevent something like that from happening, that would be something worth researching and worth working towards. And that's where I am now. But it didn't take long to realize that, in researching this, that tragedies like the one I just mentioned are really newsworthy because they're rare. Things like sinkholes and shark attacks, they capture our fears and our imaginations because they don't happen enough where we can get a handle on what causes them to happen more often than other events. And because they're natural, they seem kind of out of our, out of our ability to control things. And we like to think we have control in a lot of situations. But if you look at the data, there's not a whole lot of deaths that occur because of trees. This is a paper that's getting a little bit older now, but I met Tom Schmidlin at a researcher convention back when he just released this thing. And he looked at 12 years of tree failure data caused by windstorms. And in that 12-year period, he found 407 people died from wind-related deaths. And if you're female, you probably don't have to worry too much because it's mostly males that get injured. They're the ones that tend not to take their own safety into consideration and be outside during storms, and they're the ones who get hit. In that same time period, while 407 may seem like a lot, there's 300 million people in our country. In that same time period, 646 people died from bees in the United States, and that's mostly from allergies. I did the tour of the trees when I first got here. Did about a 550-mile ride for research. And when I was training for this statistics really kind of got to me. It was 8,000 people died in that same 12-year period related to bicycle-related deaths. And biking around Tampa, I could believe it. And then, in that same time period, almost 500,000 people died from car-related deaths in the U.S. And cars are something that we take for granted. They're a major convenience. I mean, just think if you had to walk to work every day, you'd live a lot closer to work probably, depending on where you live. Or if you had to lug the groceries that you carry to and from the grocery store by hand. There's a major benefit to cars. So we put up with this risk associated with them and car accidents to deal with that and all the things that cars allow us to do. But when you think about risk and reward and benefits, what's the reward for smoking? In that same time period, 5.4 million people died from smoking-related deaths. So risk assessment and risk management. This is how we assess and deal with the risk in our lives. Risk assessment is the process of evaluating the likelihood that part or all of a tree will fail and cause damage or injury. Yeah. And risk management is strategically reducing the tree risk given time and limitations. Recently, I think it was in Business Weekly, they talked about how Tampa is one of the greenest cities in in the world, honestly, when it comes to green views. They looked at Google Street View images, and they found that Tampa has a lot more green at the walking level than many cities in the world. And you can see that in this picture, and what happens when you have to look at all these trees and assess them for their risk, or do you even have to do that? How do you manage them given the constraints of budgets and people? And you can't get to everything, so that's where the management comes in. Risk assessment basics. When it comes to tree risk assessment, there are three factors you need to consider. One is the potential for a tree to fail. We have two different pictures here. The one on the top, if you remember from your lessons earlier, has a good aspect ratio, and the branch angle on that one branch that's nearly horizontal is pretty good, right? So that branch is stronger inherently than the sprouts from these pollards in the bottom picture that have been allowed to grow up. So, given the same stresses in nature, I'll just say stresses at this point, the tree at the top is less risky than the tree in the bottom because of its failure potential. You need an environment that can contribute to failure. I have friends in the United Kingdom, and they will let trees that are much more hollow than we would keep stand because they just don't have the weather that we have here in Florida. And if it's not ice storms in the Panhandle and north, it's hurricanes throughout the entire state, and they all contribute to the whole and partial failure of trees. And in the built environment, look at the sycamore in the bottom pictures. Those things have confined root systems. They're growing big, and there's got to be some sort of impact of that to the stability of the trees, and especially if they were to redo that sidewalk around there, or the parking lot around there. How many roots would they be cutting just because of the work that they do around those trees? And then you need to consider what could be damaged or injured given the failure. A branch like the one in that picture that's over that house, that branch probably isn't big enough to cause significant damage to that house if it fell on the roof. But that same size branch could crush a smart car or person for that matter. So the target and its susceptibility to damage really do matter. So tree failure potential. Trees fail when the load, a weight or a source of pressure, exceeds the tree's structural capacity. When you think about ice loading, it's a very static load. It's just building of weight over and over again on all the branches and the branchlets and the twigs that compounds, and eventually branches start falling straight down, given the force of gravity. Wind is a very dynamic load. We can have straight line winds that are pretty straight and consistent, but often storm winds rage and oscillate, and trees whip around. And when we do even arboricultural work, so we can even test for load before we get into the trees. So what these gentlemen are doing, and ladies and gentlemen, in the lower right, is they have a rope in a tree, and they're just kind of pulling on it to see if it moves a lot before they get up into it. They have some reason to believe that it's not stable, and they're testing it compared to other trees in the area to make sure that it is safe enough for them to get up into it. Tree failure potential is the likelihood that a tree or a tree part will fall or break. We can talk about it in probabilities, proportions, or percentages, but often we just qualify it with a rating that's visually attained. And we have to express it in a specific time period, usually 1 to 5 years given industry standards. What's the likelihood that the trees on campus that you see will fail in the next 200 years? It's probably nearly 1 for 1 for most of the species. Maybe a few live oaks could make it that long. But, so if you don't have a time period, you lose the context for your assessment. And I would say that a 1-year time period, that's probably the easiest for humans to gauge. I think for 5 years, you have to think of a lot of different things that could happen, a lot of what-if scenarios. So I think 5 years is kind of stretching it. And when you gauge tree failure potential, you need to look at defects, figure out the species, past maintenance, previous injuries, etc. So this is a little bit of maintenance and injury. This is someone who just indiscriminately cut the top of a tree out in what we call heading cuts or topping, and all these sprouts are growing back. Because what you do when you cut too many branches like that is you cut off the tree's food factory, and that thing needs to start producing as much new growth as it can, start feeding itself through photosynthesis. That really doesn't care about structure at this point. If those branches persist long enough, then they will start to grow thicker and become more strongly attached. So these things, sometimes we do this, make these trees smaller to make them safer in our minds, but you really set them up for failure. As I said, most trees fail during storm events, so that comes into our assessment. When we talk, there needs to be a target present or something that can be injured to cause a tree to be risky, right? Well, how many people hang out in parks during hurricanes? Not a whole lot, and that's probably when most trees in Florida are going to fail. So if the tree's in a park area or an outdoor recreational area, it may be less risky just because we wouldn't expect it to fail when people are around, So that's something to consider. And trees can fail with or without a storm when there's abrupt changes in their surroundings. This is a picture that I took when I was in Illinois. I was taking this picture, and the actual construction crew workers came up, and they're like, "Please don't take pictures. We weren't supposed to damage any roots when we did this work. It's in our contract." Well, I mean, you're essentially cutting half the spokes off a wheel when you do this, and that tree in a windstorm is more likely to flop over to its right because all those spokes have been severed. An arborist should be familiar with the typical weather patterns and site history when making basic risk assessments. In Florida, that's hurricanes, maybe ice storms in the north, and thunderstorms throughout. So these are all things we need to consider in our risk assessments and know that they can happen. I mentioned targets briefly before. Targets are people or property that could be damaged or injured if a tree fails. So if you look in the picture on the top, that car is obviously a target that could be damaged by that whole tree failure. Pedestrians walking by could have been injured. Often sites have more than one target, and when it comes to movable targets or moving targets like a car or a person, we need to kind of gauge how often we think people will be in the area. Contrast that with the pictures in the below. Those are static objects. They have constant occupancy on the site. So, if a tree fails and it's most likely to lean towards a shed, we can assume that it'll probably almost always hit the shed if it's leaning that way, and that factors into our risk assessment. And things like playgrounds, those will attract multiple individuals to a spot. And so that makes them riskier just for that area. If you have, say, 8 kids in that spot for 8 hours a day, we need to factor that in and maybe move the playground or remove the tree, depending on what's more feasible for the site. If there's no target, there's no risk. This is the only thing in risk assessment that can completely eliminate risk. Any tree that's of any size will cause injury. And any tree can fail if the winds or ice are strong enough or heavy enough. But if there's no target, there's no risk. So a big part of risk assessment is assessing how often a target's present. And this is something that I've done research on. And we found that arborists going to a site, during their lunch hour and hitting it up when traffic's a little bit higher, and doing an assessment then, or during rush hour, they'll be tricked into raising their risk ratings just because they've assessed at the wrong part of the day. So we need to practice that. The tree inspection process. When you're doing a visual tree assessment, it's a 360-degree visual assessment from the ground. This is what we call like a basic assessment in our industry standards, and this is the most common way to assess a tree for commercial arborists working on private properties. It's systematic and thorough. You can use basic forestry hand tools to gauge the size and the extent of defects. Often there'll be a form that'll keep you on track, so that you don't miss any key information, because that'll be critical if someone calls your judgment into question, to show that you did look at certain things and you documented what you saw and what you didn't saw, and any lingering questions you had are all there in the form. and then you work with the homeowner to get the site history. I was telling a friend that when I first got a cat, I didn't realize this, but I had what I thought was a cold for about 7 months, and I just I didn't know any better, and I just couldn't figure out what was going on. I couldn't shake it. Took all kinds of medication. Changed my habits. And I went to the doctor finally, and I said, what's going on? And he just asked me a simple question. He's like, what happened 7 months ago? And I'm like, well, I got a cat, and it just connected the dots right there. Well, you can get that same kind of information from a homeowner. You can guess as to what happened on the site and do your best based on what you see, or you can actually get the story from the homeowner. Maybe there's dieback on one side of the tree because a year and a half ago the neighbor put irrigation in on their side of the property line and cut a bunch of roots, and now it's starting to manifest in the tree. And then you don't see anything because everything's underground and the grass looks great, but underneath is some root damage that was caused by construction. So these are questions that a homeowner can give you the answer to, and you would never have seen unless you had done a real thorough assessment that you almost never have the time or resources to do. For visual tree assessment, we also look for structural defects, and this is something that we've been focusing on for some time, and there are a lot of guides out there. The Tree Risk Manual from ISA, the vast majority of the definitive advice they give is on defects. There's books by folks like Ed Hayes and Chris Luley, the Parks and Recreation folks, the National Parks folks, the Forest Service. They all have their guides for assessing defects in trees. And in this assessment, you need to know the species. This is a laurel oak. You can tell because the leaves are flat. They're not as leathery as a live oak, and you can tell in the bark and the form of the tree as well. But they have very different modes of failure. A laurel oak is much more prone to decay and root rot, and on the live oak, I've seen them completely debarked, 70% of the way around the trunk, and the wood is just completely sound when I use my decay detection equipment on it. So, different trees have different failure patterns, even if they look pretty similar to the common person. You need to know what's normal for the species. The tree on the left is a ponytail palm, essentially a giant asparagus plant, and you can see that it has a swelling at the base of its trunk, and that's normal for the species. When you look at this hardwood tree on the right, that we call it the dreaded elephant foot. That's a swelling at the base of the trunk that is often an indication that there's root rot and root damage. The roots aren't intact enough to support the tree. The tree has intact trunk wood, and it puts this large and enlarged growth down to kind of buttress itself and kind of keep itself from swaying where it can, because the roots are compromised. One's perfectly fine, one's a cause for concern. It all depends on the species. And the species, again, depends on the structure and form. The branch that twists off to the right there, it would be called an overextended branch on most guides that you see from the Forest Service or ISA. But for live oak, that's normal, and I wouldn't have any concern for that. It's probably riskier than something that's less extended, but for the species, I have little concern for that. And then signs of decay. Signs are positive indicators of decay, that there's definitive proof that there's decay going on, and those things could be things like conchs or cavities, or even some sort of insect shavings from certain species that mostly burrow through decayed wood. Tools for visual tree assessment include just your basic measuring tools. So a D-tape's important because you can figure out how big the tree is and how much damage it could cause if it fell on something, because size directly relates to consequences of failure. For hypsometer, just think about this. If you look at that hypsometer, which measures tree height, you figure out the tree is 60 feet tall, and you're worried about the base of the tree failing, you need to make sure that things within 60 feet of that tree are clear. The tree can only fall as high as it can go, and maybe things can bounce a little bit if the tree's dead, but for the most part, height indicates how far it could reach. Binoculars are great, especially if you're in the Panhandle north of North Florida. Trees are a little bit taller than they are in South Florida, and you can see defects much better with binoculars from the ground than you can from your eye alone. I'll show you sonic tomography in the next couple slides, but this is the original sonic tomography, the sonic sounding method of sensing decay. If you take a rubber mallet like this and you bang on the side of a tree and it sounds like a bongo drum, it's a bongo drum and it's hollow, and you can do something with that information. We'll show you that at the field day. Probes, if you have a cavity, you can stick something in the cavity to see how big the hole is. I wouldn't use your hand for obvious reasons, but a measuring stick can help you gauge how bad the decay is. You could also look at a compass, a GPS. Part of that is to assess where the tree is on the site so you can get back to it. But also there's these things called wind roses. These are things that different airports will put out. The one on the left's from Fargo, North Dakota. And you can see in Fargo they have very strong and discernible northwest to southeast winds, right? So if you have root damage or damage that falls in line with those strong winds, you're more concerned than if they're going the opposite direction, right? Because if the roots are severed in the northwest quadrant or in the southeast, that's the direction where it's most likely to topple. Look at Clearwater, Florida. It's all over the board. There's not a whole lot of pattern there. It goes all over the place. So, but in some areas, this can be really telling. You can have a shovel. You see some of these root defects that we've talked about. You don't know how bad they are until you start digging. Maybe there's constriction going on below ground, and the stem might be a failure point because our root's pressing up against it. You'll never know until you start digging. When you do an inspection, you need to kind of convey that risk to the clients, and that's usually a written report. I would only recommend a written report if you're doing this for a job, and you want to tell them where the failure is most likely to occur. So in this case, it would probably be that branch where the shell wall of the branch is completely eroded all the way up to the top, and it twists around. That thing's just ready to twist off and torque and break. What conditions would trigger the failure? Is it something that could fall on a blue sky day, or is it something that would only fall during a storm event? There's a big difference there. What targets could be impacted? You can, point out nearby buildings, pedestrian corridors, roadways, things like that. Show what targets are you talking about, because again, target matters. A house is way different than a person when it comes to resiliency. And then lingering uncertainties. So if you have like this has a fence blocking half the tree, you can't see what's on the other side. How are you supposed to do a full assessment? Especially if the neighbor has a dog or something there and they're not around to let you in. You just can't hop the fence and trespass. So, and then as part of the assessment, you offer some risk management strategies and the associated costs. Every tree has some risk, and how risky it is kind of depends on how much care is worth it. And then the size of the tree and the value of the tree also matters, because you don't want to cut down a tree because a few branches are dead, and you convey that in your report. Defects. Defects are imperfections, weaknesses, or injuries that can result in a reduction in the tree's structural integrity. Trees are pretty cool. Look at this thing. This thing is a green, healthy tree with a completely compromised structural system. It's completely hollow, and not only that, but the shell wall on the outside is completely compromised. If you take a soda can or beer can when it's empty and you press down on it, it can support a significant amount of weight for the thinness of the metal that makes up the shell wall of that can. But now take that can and just pinch the sides a little bit to break up the structural integrity of it, and now push on it, and it'll crumple a lot easier, right? Well, trees are the same way. And there's a relationship between health and stability. A healthy tree can outgrow defects and bolster its some defects and bolster its strength. A tree, but it can still be hollow like this one, right? So health doesn't mean a tree's safe, but if a tree is unhealthy, then it's just going to fall apart over time because it won't be able to maintain its structure. So health is important. It's not a two-way street, but there is a relationship both ways. There are different types of rots or decay. When you think of wood, look at that column in the bottom picture. So that column is concrete with rebar in it, and that's a good analogy for what a tree is. The lignin of the wood is the concrete, and the cellulose is the rebar. So white rots attack the lignin, they eat the concrete, and they leave the cellulose, which is the rebar. And what that does is it reduces the compression strength and the stiffness, because concrete really makes things stiff, and you put a lot of weight on the concrete. The rebar, if you just had like a roll of rebar and you put a lot of weight on it, eventually it would just crumple and bend and flatten out, right? With the concrete there, it's very stiff and resists a lot of compression. But the rebar is what makes the concrete more strong when you have bending strength. So I had a sidewalk that a patio that I'm taking out in my backyard, and I cut stuff out, and I was wailing on it with a sledgehammer, and the rebar is what kind of holds it together when you try to bend it with the blow of the sledgehammer or just the loading from wind and stuff like that. So brown rots, they attack the cellulose and they leave the lignin. They look really blocky. They're kind of cool, and they reduce bending stress. And often they're in conifers and pines, but I've seen them in like red oak in the north. And these things you may not have any indication that they're going on inside until that tree falls over. So they're pretty cool. They're pretty scary, but they're important. Soft rots are a mix of the two. These are less common, and they usually attack the cellulose first. We don't know a lot about them, so there's not as much information about them. In addition to like what decay will attack in the actual wood itself, they do attack different parts of the trunk and different parts of the tree. So heartwood, as you know, is like a one-time chemical defense to protect the inside of the tree and make it more rot resistant so that you can maintain that structure without having to continually actively manage and fight decay. It's like a chemical barrier, one-time deal, set it and forget it. Well, heartwood rots are rots that have adapted to attacking this wood. And anytime there's a defense, it just takes a couple thousand years, and something will exploit that defense, and then the trees will develop a new defense over time, and then that'll be exploited again. So, sapwood rots are, in the converse of that. So instead of attacking the hardwood in the center, they attack the sapwood on the outside, and these are the most alarming. You can see they often have these tiny little fruiting bodies kind of all over the place, and that's common for sapwood rots. And when you see that, that's bad because it just like that soda can example I gave you before. The outside of the tree, that's what does a lot of the load bearing for the tree. And if that's damaged and that's compromised, even if there's solid wood in the middle, you lose a lot of the width of that column, which is what makes it strong, right? And so we're concerned about that. And then, those were heartwood and sapwood. You can also have things like basal rot or butt rot. So this is beyond like the inside and the outside of a stem. You're looking at an actual part of the tree, an organ of the tree, which is the roots or the base of the tree. So potential indicators of decay are anything that could potentially, I'm using the name, they're not definitive indicators, but they're likely indicators that something's going on. So these could be wounds, pruning wounds, or what have you, missing bark, oozing, cracks, response growth being swelling, that often indicates that there's a weakness that the tree's trying to overcome. Contrast that with signs of decay. Signs are things that are definitive. We know there's decay because these exist. Those could be conchs or mushrooms that are actually on the tree itself, not in the mulch. That could be something that can confuse you. Cavities, carpenter ants, those are all usually signs that the tree's already decayed. We can do sounding and probing. I talked about that before, to get the extent of the decay. Other defects include cracks. When you have a shear plane crack, you think of, when a tree, there's when the wind's pushing on it in one way, there's one part that's under tension and the other part that's under compression, and there's a neutral plane where those two pieces meet. And sometimes the force is going to be so much that there's a slipping at that neutral plane, and it splits apart. And those are pretty bad. When you add decay, they're worse. But the worst of the worst are the horizontal cracks. When you have a crack like the one picture in the right, that's a very dangerous situation, and that thing's going to come down a lot faster than the other two. Codominant stems. We're going to do a demonstration about this on the field day. If you have a U-shaped codominant stems, where the stems are about the same size, coming from the same point, that's a lot less concerning than a V shape, and we'll show you that. But included bark has a lot to do with that. So, adventitious shoots. They can be low risk if they've been on there quite a long time and have actually grown into legitimate branches. If they're brand new, like the pollard in the middle picture, they can be a possible cause of failure. But again, they're much smaller than a normal branch. That's not as alarming for risk point of view. But when they have decay like the one in the right picture, that's the most concerning. Often you'll top a tree, or it'll be topped in a hurricane. So that's the indiscriminate cutting of a tree, between, branches. And what that will do for weak-wooded species, it'll hollow out that branch. At the same time, you have big adventitious shoots that are growing at the rim of that decay, putting weight on like one side, and it'll eventually just kind of peel off to the left there. And I've seen this many times in like silver maple in the north and other weak-wooded species down here. It's a bad situation. Branches that come from the same point, that's a concern. This could be because of the cultivar. Often some of the really upright growing species will do this naturally, the cultivars. But it's also often tied to nursery production. Certain things just look like a stick when you produce it in the nursery. So they'll cut it, they'll top it, just that one terminal bud, and then it'll just start branching like crazy at that one spot. And it makes it look tree-like so we can sell it, but it's setting that tree up for failure in the future. When you have dead, broken, and hanging branches in a tree, these things are essentially failing before your eyes, and it's only a matter of time before they fail. So these are the worst of the worst. These are things that anyone can recognize and need to remove from the tree. Seams and ribs can be a sign of decay, and they can actually confounded with decay. But they may not be that concerning. They're just something that people have noticed. Leans and bows. So if you look at the corrected lean picture, that is a tree that probably had some root issues when it was transplanted. It blew over, and then with time it stabilized, and it started to grow straight up and down through gravitropism, right? So that's not as bad as the one picture on the right that has the flowers around it. That's a tree that has no correction whatsoever. There's no sweeping. It had some root failure. There might be some heaving on the side that's the tree's leaning away from, and that tree's moving. You can put a level on there, like a digital level from Home Depot, and monitor it over a week or two and see if it's moving. But a tree like that you probably just want to remove. And then there's bowing, which is when a tree grows towards the light. Often you'll see that, and again that's like an overextension of branches, but it's less alarming than uncorrected lean. Here are some, so all those things that we showed before had designations from the track manual on how serious they were, going from improbable to imminent, which are some of the terms that are in the track manual. We won't go into them too much, but these are all the ones where we have really no idea. So they're bad, but we don't know how bad. So Species profile and site history. Trees often evolve to survive in their given environment. So sand live oak, I love this tree. It's like live oak's scrappier counterpart, and this is a species that has grown in the state and is very resistant to hurricanes, according to some Mary Derrier's work from the 2005 and 2004 hurricane season. But problems occur when you move plants from elsewhere, like Mexican fan palms. Those are sables in that picture, but and things that aren't prone to hurricanes, they can get really beat up. There's a lot of tropicals out there. My neighbor had a rubber tree, a Ficus elastica, that typically isn't doesn't experience what we have here in Florida, and it just tore itself apart. And that's one of the rubs when we try to introduce new species to the urban environment. And over time, practitioners have noticed these species-related failure profiles, and we document them in things like the International Tree Failure Database, or when that ultimately trickles down into our guides and our risk assessment methods. So site history, if you do a little detective work, you can look at past failures. Often, trees, if they failed before, they'll prune it, and you'll just see the pruning stub. You may not know why the limb was pruned, but it may be some lingering issues that keep occurring. The city of Tampa, I think they have like a 3 strikes and you're out policy for their trees. If they drop limbs 3 times, it's time to get rid of them. That might be unofficial, but what it does is it lets you focus on the trees that are better suited for the sites. Rather than putting all your efforts and all of your inputs into the trees that are falling apart, you get rid of them, you plant something new, and you have more resources to focus on healthier trees. Past construction events, I mentioned this before, but once that irrigation and conduits all put in place, and the grass back and it's grown in place, you may have no idea what happened at that site. Historic weather events, changes in environment, maybe I got called into a site once, and there was a bunch of trees that were drowning on the site. They had pretty much cattails growing in the lawn. He's wondering why the live oaks are looking really sad, and I told him it was water, and if that landscaper cranks down the water in response, now you have root rotted trees that are going into drought conditions, and it's only going to set them up for death and for failure. So those sorts of quick changes can really wreak havoc on trees. And then what's the origin of the tree? These are remnant trees. Often what people will do is they'll take a forested lot, they'll do a timber harvest, and then they'll leave a few trees to sell it as wooded acreage for house building. Well, you take a tree that's from the interior of the forest, and you now have it completely exposed on all sides on compacted soil that trucks have been driving all up and down, with a grade change maybe in there, and then you wonder why they're dying over the house that you just built. That all has to do with all the stuff you've done and the origin of the tree. It wasn't something that was planted; it's a remnant from that site when it had a much nicer site to grow on. Advanced inspection techniques. You're going to see all these in a little bit. So when we're up in Gainesville, so hopefully you enjoy them. They're pretty cool. I would say they're mostly for a researcher or a really advanced practitioner, but they are available, and we're just going to introduce you to them. So, we have a drone in my lab, and they're pretty cool. Forget doing aerial inspections. Anytime you get off the ground, it's called an advanced assessment, and you can do that if you're in a bucket truck. You can climb if the whole tree is okay, but you're just looking at a few branches. And now with drones, it's really easy to get some high-resolution images from a bird's eye view to see defects that you can't see from the ground. You can do decay detection. This is a low-tech way of measuring decay. You just take a drill, you skewer a little foam ear, hearing protection device, a little earplug, and you start drilling into the tree, and you listen to that drill. It'll wind up and go, and as it hits a decay pocket, it'll just drop down and pitch, and you can tell that it's working less hard. And you just pull it out, look at where that little ear plug is, and that's how far you've gone into the tree. You can also check the color of the shavings, Healthy wood tends to be a lighter color than decayed wood, especially if you have things like the brown rot like we saw. You don't have to go too far. If you generally we say if the tree is 30% solid, it's probably okay. So if you go in 15% on one side and you haven't hit decay, you don't have to go any further, right? I wouldn't recommend these. These are mentioned in the book, but this is a increment borer. They use them in forestry to gauge growth in trees when they're trying to see how long they'll be before they can, extract timber from a property. These things are terrible in anything but conifers. These were developed by the Norwegians and the Swedish in the conifer forest of the north. You get these things in a live oak. If you stop turning it, you will never get it out. So just don't use them. Resistograph or resistance recording drill. This is a drill that has a device that measures the resistance of the drill bit as it passes through a tree. The more resistance the drill bit goes up against, the more solid the wood is. And here's the output. You can see going from right to left, there's very little resistance in the bark. And then as it hits solid white wood, you see that resistance go up, and there's peaks and valleys for the different rings of the tree. It kind of, as the wood starts to dry out and split by the decay, you have a decrease in resistance, and then right at the barrier zone, where that decay really starts, there's a jump up again. We see it a lot. And then as you get into the actual decayed wood of that tree, there's no ring marks. Those highs and lows are gone, and the resistance drops significantly, right? So this is a really easy way to detect decay. It's a little abstract, but visuals like this really help you put into play. This is from our equipment. We have digital output on ours. And the top picture is what you'd expect on a healthy ring porous tree like a live oak or a elm. You've got a little bit of resistance for the bark. Right at the 1 inch mark, we usually see a dip for phloem rays. And then you have a steady increase, a gain in resistance as you go further and further into the tree, going from right to left. Contrast that with the picture below. There's a little bit of an increase, and then it levels off between 3 and 4 inches, which is showing you that there's partially decayed wood. And then there's a cavity right behind that thing flatlines, and there's absolutely no ring marks. Our subtropical trees don't have a lot of rings to begin with, not like the one you saw in the picture before, but we see none of that in the output there. I mentioned that a hammer is the original sonic tomography, but this is the more robust and the $20,000 price tag sonic tomography. This is a piece of equipment we have. What it is it's like an X-ray for a tree, but they use sound waves instead of radiation to look inside of the trunk. You just put all the sensors around the tree, hit it with a hammer, and the time of flight of sound waves from point to point, all those little sensors, gives you an estimate of the tree stability, and not tree stability, but wood resistance and wood solidness. You can see there's some calipers on the ground there next to that tree. As trees get older, they get more amoeba-like, and so you can't assume it's a round shape. And these calipers, they allow you to measure the shape of the tree pretty well, and then get you a really good starting geometry for the measurements. This is interpreted as brown is solid wood, essentially. Green is kind of punky wood. Pink and blue being more of your hollows or your cracks or fully decayed wood. So cracks pose a problem for this technology because if you have sound waves going from east to west and north to south in this picture here, they'll hit two different directions and they slow down in two different directions, and the way the computer sees that is one big hole in the center, even though there's a lot of solid wood there. So usually sonic tomography is backed up with resistograph. What sonic tomography offers is a very good visual for homeowners and decision makers because resistograph output's just really hard to interpret, and this is very, very intuitive. If you want to do a root zone inspection, that's a higher pay grade, that's more work. You can use an air spade, which we're not going to actually have demonstration on. It's really messy, but that allows you to easily access the roots with compressed air without doing any damage, and you can see what sort of train wrecks are below ground, like this picture right here. And all those methods before, there can be used to be punched into engineering equations to see how strong we expect the tree to be. But there's a way to just measure this, straightforward, and that's with static load assessment. What you do is you put these sensors, there's tilt sensors and strain gauges to see if wood's stretching, and a force gauge, and you sync them all up, and you pull on a tree in a direction to a very small amount, like 1 degree, and you can tell how wind firm that tree is compared to its peers through this equipment. It's kind of a direct measurement of rooting strength or branch strength. So risk management and mitigation. Mitigation is the process of reducing failure potential of a tree. And that's what the book says, but, it also comes on the targets. If you can remove the targets, like, from the site or exclude them somehow, you reduce risk without doing anything to adjust failure potential. You can prune and reduce the trees. I think Ed had some trees on his property that were damaged from Irma. And what he did is he reduced the crown by just cutting the outermost branches off, and that reduces the wind sail effect for that tree and allows the roots time to kind of grow back and gives the tree a break while it's getting its structure back in shape. The growth is going to be reduced from this, both above and below ground, but it's better than having the tree topple in the next storm. Health management, I said before that tree health is related to structural integrity. So if you have a tree with moderate to minor defects and it's on a poor site and you want to give that tree a chance, you can really invigorate the site. This is radial trenching that's reducing compaction around the tree. And if you can increase the health of the tree, you can give the tree a chance at outgrowing any defects that it has by putting more wood on. You can sit back and monitor trees. I was looking at some trees today for a coworker at her development. And there's a few trees there that had been marked for removal, and then she said they had taken the tags off of them, and I agreed with that assumption because they weren't going anywhere anytime soon, but they were something to keep an eye on for the future to see if they pulled out of their state of decline or if they were going to just continue to get worse and worse and eventually start falling apart. But they were really nice trees, and not anything you would want to just remove with a knee-jerk reaction until you had more information to make a better assessment. You can do cabling and bracing. We're not going to talk a lot about this in the class, but if you have codominant limbs that are moving around and you're worried they're going to split at the branch union with the included bark, you can actually tie them together. These things have slings that kind of open up on their own, so they won't constrict the branch, but you have to keep adjusting them. Or you can use metal systems that'll drill right through the wood. And what that does is it just prevents excessive movement. It allows for a little bit of movement back and forth, which the tree needs to keep growing and putting on more wood, but it doesn't allow the tree to grow or move to a point where it's going to fall apart. You can restrict access. This is a really old tree in the UK. Why would we remove a 500-year-old tree if we can just put a little fence around it? And then people can still enjoy it from the safety of beyond where the tree is going to fall, right? And you can see here that it goes a little bit further to the left because that's where the tree's leaning, And this also has the added bonus of keeping people from compacting the root zone beneath the tree. And you can move targets, things like picnic benches and stuff that are right next to a tree that's bringing people to it. Just move them away, bolt it down so people can't move it underneath the tree because they will because it's shade, and you've reduced the risk of the site. And finally, we'll talk about liability and negligence, just because it's in the book. When you have a duty of care, you have some level of responsibility. Tree owners, if you have a tree in your yard and you own your property or your landlord owns it, either you or the landlord has some level of responsibility to ensure that the tree is safe. So if your tree is a train wreck, it's going to fall down, and if someone tells you this, now you have been informed and you have to do something. What you do is up to what the standard of care is. Arborists have a duty of care to report risks that they witness. So this could include, if they're on a site and they're looking at other trees and they walk past one that's obviously defective and obviously a concern, they should make a little note and say that to the homeowner, and then continue doing on the work that they were contracted to do. They just can't ignore that, given that they have more advanced training than the general public. The standard of care is the degree of care a reasonably prudent person would take in a given situation. So you recognize the risk, and now what are you going to do about it? And is it something that's industry approved? So all those treatments I mentioned before for mitigation, those are things that are in the ANSI standards, so they're good. People often do all sorts of rehabbing and homemade inventions to protect their trees and protect other people around them. And often these do little to help the situation. So they would not be up to the standard of care, especially if you have the training. Liability, that's if something happens, you need to establish liability, negligence, and then some sort of cause, and liability is, do you have a legal responsibility? If you're the homeowner, we just told you that you do, and negligence is that there was injury or damage that was linked to a failure to exercise due care that we talked about before. And then the causation is linking that injury or damage to your lack of action. So can the injury or damage be directly traced back to a person's actions or inactions? Did you prune a tree poorly and now the tree fell apart because of that? Or did you notice that something was at risk and you didn't do anything? Those will be causation. And then, proximate causes, was the injury foreseeable? Which is, it's easier to say that in hindsight than it is to say it on the fact. And that's the thing, is if you often, consultants would called in and just run you through the ringer, and it's because they have the gift of hindsight when assessing these situations. But if you do a risk assessment and you follow the industry practices and the established methods that are out there, you've done what you can given the information you have. So with that, we're done with this lesson, and I thank you for your time.